Okay, so now we will start with the first topic, which is the atomic structure and how did we or the scientists reach the current knowledge about the atomic structure. So in the very beginning, we will of course think that people didn't know anything about the atomic structure and even didn't know anything about the atoms before. And before 1800, the scientists knew nothing, and there were some philosophers like 1,000 years ago or more just said that there's something that is there in the matter and we don't know anything about it. But in the first, in the beginning of 1800s, the scientists started to put theories about the components of the materials. And the famous, or the most famous of them, is John Dalton. He was the first chemist who suggested the word atom and molecule, and he said that atoms react together to make molecules. And this was very little knowledge about the atoms, of course, until the late 1800s. And this is what we're going to cover in this video, is what is the knowledge that people have about the atoms and the atomic structure in this period before the kind of breakthrough of the knowledge started in the beginning of the 1900s. So the first, or from the first people who did the experiments on, or did experiments to figure out what is the component of the material, his name was Henry Cavendish. So he was the first person to produce hydrogen, and it was a very simple experiment. Actually, you can do it in at home. You can get any metal or aluminum foil, whatever, and put it in a plastic bottle, like a Coke bottle or something, and then pour acid on it. If you have a balloon and put it on the cap instead of the cap of the bottle, the hydrogen will be produced from the reaction of the metal and the acid, and then it's gonna fill the balloon. It's a very famous experiment, and you'll find a lot of videos on YouTube showing how to do this. So he did something similar, of course, without using balloons or something. It was with experimental materials, but he was able to collect hydrogen gas from reaction of metals and acids. And he didn't even know that this is called hydrogen. He called this inflammable air. And this is what you should expect at this time, that they knew the materials, but they didn't know anything about them. They have acids, they had bases, they had metals, nonmetals, and all these materials were being used a lot in their daily life, but they didn't know a lot about the components of the materials itself. So he called the hydrogen the flammable air, and then he started to do experiments with hydrogen, and he was able to make a reaction between hydrogen and oxygen, and found that this produces steam. And he did a lot of experiments until he reached the observation, or the conclusion, I'm sorry, that the hydrogen reacts with double or with half the amount of oxygen. So you have two volumes of hydrogen with one volume of oxygen to produce two volumes of steam. So if this is 200 milliliters, this is going to be 100 milliliter and produce 200 milliliters. So um, uh, he found this observation, and he didn't come up with a conclusion out of it, but it was a very interesting observation at this time. And this experiment was done also by another scientist whose name was Gay Lussac, and he confirmed the same thing with other reactions and other gases. Um, and this was the first time to notice this, or this observation was the first time to get some kind of solid observation that there is something really inside the material that reacts with some proportions, not just any random reaction. And by some means, he was able to calculate the atomic weight of the hydrogen and found it to be the smallest atomic weight, and he used it to be the reference of the atomic weight. One thing that you need to know about this topic that we are covering today, that I'm not going into all the details. There are a lot of details that I don't know, and at that time there are a lot of scientists who are working on this topic, trying to figure out what is the atom and what is the components of the atom or the material. There might be some knowledge that was being transferred from one scientist to the other, and I don't know exactly who did the experiment before the other. Some of these scientists are very famous, like Avogadro, and some of them are not very famous. So, we are just here covering the main parts or the main milestones. If somebody is interested, you're free to read more or to find more information about it on the internet or in any other textbook. But the point that I want to make, that he was able to calculate the atomic weight of hydrogen and used it as a reference. According to Dalton's assumption that we mentioned in the very beginning, we said that he said that there is something called an atom and something called a molecule that is composed of reaction between atoms, and he assumed that the reaction should be in a ratio of 1 to 1. So if hydrogen reacts with oxygen to produce steam, then steam is OH. And this is how he thought of hydrogen, of water or steam. And accordingly, he calculated the atomic weight of oxygen, and it was totally wrong. It was around 7, I think, which is not right. Then, after the observation of Gay-Lussac and Cavendish before, another scientist did more experiments, and his name was Berzelius. Berzelius was able to use these observations and to calculate the atomic weight of oxygen. And before that, he suggested that if you have two gases that have the same volume, then they will have the same number of atoms inside, which is true in case of ideal gases. And this was very crude assumption, and it was okay at the pressures that they were working at that time. So again, he was able to calculate the atomic weight of oxygen, found it to be 16, and they found that the reference, if they used the reference as 1/16 of the atomic weight of oxygen, this would be more accurate and would be going more accurately with the results of their experimental calculations of their experiments. I'm sorry. So after Berzelius, the reference now is 1/16 of the atomic weight of oxygen. And then they repeated the process on different reactions. So from the reaction of steam and oxygen, they were able to get the atomic weight of oxygen, and then they reacted oxygen with nitrogen. They were able to get the atomic weight of nitrogen, and so on. So from a reaction, from other reactions, they were able to get the atomic weights of other materials like chlorine, iodine, and nitrogen. Berzelius did one more interesting thing, that he was able to predict the atomic structures or the molecular structures of materials of other or compounds based on the amounts that they are reacting with. So, for instance, he was able to react 1 gram of phosphorus with 3.44 grams of chlorine to produce what they called at that time the lower chloride of phosphorus. So again, they had acids, they had bases, they had everything, but they didn't know what these things are. So they knew that there is a chloride of phosphorus, and there is another chloride of phosphorus. One of them is produced from reaction of a small amount of chlorine with phosphorus, and the other is produced from a reaction of a large amount of chlorine with phosphorus. They have different properties, so they called the first the lower chloride of phosphorus, and the other is higher chloride of phosphorus. They didn't know anything about the atomic structure or the molecular structure of both. But when Berzelius did the experiment accurately, he was able to know that this is 3.44 grams of chlorine are required to react with 1 gram of phosphorus to produce the lower chloride, and 5.72 with 1 gram of phosphorus to produce the higher chloride of phosphorus. So with simple calculations, he said, okay, I can say that the number of molecules reacting here to the number of molecules reacting there equals to the mass to the mass. So this is 5.72 divided by 3.44, which is this and this. and he found it to be 5/3. And from this observation, or from the results of this calculation, he was able to tell that the lower chloride of phosphorus contains 3 chlorine atoms for every phosphorus atom. So it looks like this, and the higher was looks like this, which is true. And then he was able to calculate the atomic mass of phosphorus. Of course, he was kind of lucky because he did the experiment on different materials or different elements that reacted in the two reactions with the same number of atoms. So here he has only one phosphorus atom, and here he has only one phosphorus atom. So in this case, the calculations would be okay. But if you have something like, if you are using the same thing for nitrogen, sodium oxide, which is Na2O, and sodium chloride and NaCl, then you would never get the accurate or the right results, because the number of sodium atoms here that are reacting are different from the number of sodium atoms here that are reacting. But he was kind of lucky because all the experiments that he did were going the same way. Only one atom here reacting here, and only one atom reacting on the other reaction. So this is kind of the basic knowledge that they have. They did some other experiments and calculations. I'm not going to go through these details. They did calculations based on the heat capacities at constant pressure and at constant volume, the vapor densities, the crystalline structure of solids, and other things, so that they can predict the atomic weights of materials. And then after some more experiments, they were able to change the reference atomic weight from 1/16 of oxygen to be 1/12 of carbon, which was even more accurate than the 1/16 of oxygen. So this was the basic knowledge that they had till the end of 1800s. And in the next video, we'll start to see how they figured out the components of the atom. So till now, they didn't understand what are the components of the atoms. Now, or in the next video, you'll see the experiments that the scientists did to know that there is something called electron, something called nucleus, and so on. So I'll see you then, inshallah. Goodbye.